If you want to learn AI engineering and get hired in 2026, do this. For me, 4 years ago, I set a goal to break into AI engineering. Now, Apple, Google, Meta, they're headhunting me without actually applying for the jobs. In the past, I've built AI systems for self-driving cars that drove on a closed track, and I even built AI system for Apple Vision Pro. I can definitely say firsthand that the AI job market is not cooked. In fact, it's one of the best moves to do in 2026. And here I'm going to share everything that I've learned. I started from the film industry, Hollywood films, and 3D and AAA games, and then I transitioned to AI. And the thing is, I'm going to show you how to become an AI engineer fast, what to learn and why you need to learn it, and how to build AI projects that actually matter. And what's most importantly as well, that's missed by a lot of tutorials that you see on YouTube, is actually how to pass AI interviews, because that is half the battle. So let's jump straight into it. First, let's start with the programming language of choice. Basically, nowadays, Python is non-negotiable, mainly because every AI framework uses Python, research papers centered around Python, and production ML systems or machine learning systems use Python. It's not necessarily that Python is the best language. You could actually build AI, machine learning architectures from any language at all. It's just that Python is what's used and what's the standardized. So instead of adding extra friction, just use Python. Basically, I learned AI fast using Python as a base because that's the main thing that's used now. And when I started years ago, when ML, you actually didn't have basically frameworks like PyTorch or TensorFlow. You had to build it from scratch. So at that point, people did use different languages. And the thing is, as well, is that I already knew web development. So combining with Python base was pretty easy. However, Python alone is not enough. You need to also understand the engineering side of things, right? So that also includes APIs, which stands for Application Programming Interface. So knowing like Fast API or Flask, which allows you to link your backend or the data processing part or the machine learning part backend interface with a front end using basically like the API with it and using like endpoints or whatnot. And that's more like front end, backend, that's more like web applications, right? The other things as well is also cloud deployment. So you want to learn AWS or Google Cloud Platform, and also cloud or basically Docker for containerization, right? So basically your system, your backend, everything you built with Python, all your systems in there, and like your machine learning models that you have that are in inference, you want to containerize it so you can deploy them in your backend. And the first AI job that I had was predicting the stock market. So I built prediction models by reading the latest papers and then actually implement them into an actual model. And it had to beat, for example, a benchmark like the S&P 500. And so if your model that actually made money versus just playing the S&P 500, then you were successful, right? And what's surprising is the actual algorithm itself or the design wasn't as complicated as actually deploying and monitoring the model by actually putting it into the system. So it took less time to actually train the model than it actually was to deploy it and manage it and actually use it in real time. So the main reason why I was hired was not because I'm able to just read papers and I use machine learning. It was mainly be able to read papers and use that to be basically productionizing that ability and make it into an actual final product that actually works. So Python plus production skills is what actually gets you the job. And this is what actually separates you from being a hobbyist from an actual engineer. So how do you actually learn? We already picked Python as the main language you're going to learn from. Now, we need to learn basically AI from that, right? So this is going to be a little different from traditional tutorials, not just going on YouTube and just looking up how Hello World in Python. You do need to learn that stuff, but that is not the main goal. What you want to search is like go on YouTube and search building AI systems from scratch. You want that specifically, not AI theory. That you don't want that, and not ML or machine learning mathematics, because you're not trying to be a researcher. You're trying to actually use AI systems at the end, right? You really want to focus on building the actual systems. So choose end-to-end tutorials that show you from start to finish data collection, data processing, model training, and actually deployment and seeing it actually work from beginning to end, right? I would say avoid 12-hour boot camp straps right here, where you're just watching and not actually becoming an engineer. They're just telling you a whole bunch of like theory and math and whatnot. If you want to become a researcher, that's fine. But even then, in that case, you actually have to go through academia and go to school. So if you actually want to become an AI engineer, you want to focus on actually building system and go from the beginning to all the way down to the end, where you actually have something that's actually working. Past mistake that I've done, because you could go down a rabbit hole by searching on YouTube for videos and whatnot, is just by consuming and not actually building. So the first time I gave up after like trying to do a coding exam, any attempt, because I didn't have any real goal at the end. I just like, hey, I want to learn machine learning or AI, and I just kept watching videos after videos after videos, but not actually doing anything. What I find out that it works out actually well is building tiny scripts or tiny code. That works more than doing like some monolithic, big, giant application, because those tiny scripts, one, they're helpful, they're quality of life things that help a lot, and two, they build up over time. You could chain them together. So start stupid simple, make sure you could get to the end and actually finish. And you could be like your first AI project example could be like a digit recognition, like a Ministra set or something. Yes, I know it's simple, but at least you get your feet wet. It goes from beginning to the end, and then you get more complicated. For example, yeah, the Ministra or just digit recognition is not revolutionary, but it eventually, for me, I was able to upgrade that concept to a Sudoku solver. Now you have to bring other concepts into it, like image recognition, stabilizing, figuring out where the grid is, then figure out the digits, then interpreting that, and then applying an algorithm to actually solve it, then re-represent those new images overlaid onto it and project it back on. And basically understand every line of code. That's why you want to start small, so it's easier to understand smaller things, and then you build up on it, because complexity is just compounded simplicity, right? So once you know a lot of simple things and combine it together, you know how you understand the complicated things. And the only thing I found is I actually learned by actual building systems, because I know there's an end goal, and whether you make it or not, that is your metric. So you can tell if something's working, and then then you can assess, okay, why isn't this working? And you get better at that. Not just by reading papers for the sake of reading it, and not just by watching lectures and not actually applying anything. Let me tell you my actual tech stack. So one thing I would say is master one approach and learn it deeply, right? Avoid shallow multi-frameworks. For example, you gotta learn PyTorch, and you gotta learn TensorFlow, and you gotta learn JAX, things like that. Learn one, master that. If you're required to learn another one, if you know one, it's a lot easier to learn another, but have a reason, drive that, be that motivation to learn something else, not just for the sake of it, or else you're gonna go down a rabbit hole just learning, and not actually applying. This is what actually got me hired, right? So the traditional machine learning tools that I would say you learn at first to understand the basics are like scikit-learn. It's a Python module. XGBoost, Pandas, that is kind of like dealing with tables of data. You could export out Excel sheets or like CVS, or CSV's comma separated value tables, and then manipulate that. And all these boring tools are the ones that made money, right? When I worked actually at predicting the stock market, these are pretty much the tool set that's used, right? And the deep learning choices, I would say once you've learned the traditional machine learning, the basics, and then you want to start going to deep learning, PyTorch, like I mentioned before, that's because that's kind of the industry standard right now. It's from Meta, and it's basically cutting edge papers use it, right? And every time there's a new paper and new implementation or new research, I could just use it right away because I'm already using the same tech stack, right? And for large language models, LLM application stack, I would recommend using LangChain and vector databases as well, right? And over here for the deployment stack, actually once you actually build everything and you want to deploy it and actually use it, you should learn Docker for containerization. Basically, that is kind of like you have the entire environment, kind of like a mini computer inside that you could containerize it and send it wholesale and everything will work. And you'll avoid the problem of, well, it works on my machine, and then you try to give it to someone else and it doesn't work, right? Either Fast API or Flask as well, and learn cloud services such as AWS or Google Cloud Provider platform. I would recommend learn one, not necessarily both, because there's like Azure as well. I've worked with those three, and I worked with them mainly based off of the fact of that the parties I was working with, that just happened to be the cloud service they were using. That was pretty much it. The first one I started off with was AWS, but then I had to use Google Cloud, so I learned it. But again, if you know one, you can learn the other. So I only learn it mainly because of necessity, not because I'm just going to learn it for the sake of it. Because as long as you learn one, it's not that hard to learn the other, because they all work the same, a very similar way. And most important missing skill, I would say, is actually work with real world messy data. I know there's like Kaggle data sets, and there's also like a lot of consensus like surveys are being done. You could use data sets to learn at the beginning. Maybe when you first starting off like learning ML tools, you could be learning with like curated data sets that are already clean and everything works out and all the information's already in there. So you just focus on the techniques, but in the real world, it's all messy. So you can't necessarily work with Kaggle data sets, because in the real world, there's missing values, are not consistent, inconsistent formats. There's edge cases. So a simple example of it is just the date. There's no standard way of representing the date, even within the same country. You know, you could have month, day, year. You could have year, day, month. Then you could have day, month, year. You could have it where the format where the year is represented in 2 digits. Some of them is 4 digits. Some people actually rate out the month as in like January will be JAN, and sometimes they put the full name, sometimes they don't at all. So dealing with taking into consistent formatting and actually cleaning it, making conforming, that is a very important part. In fact, there's a methodology, a framework for how to work with this. It's called the Awesome Framework right here. It's pronounced awesome, however, that's how it's spelled. And it stands for, O stands for obtain, S is scrub, explore, model, and N is supposed to be like the interpret part. So basically, you obtain the data from the real world. Then you scrub it, basically clean it, make it conform, like for example, the dates. You have dates, so you have missing dates, you have dates that are different formats. You want to scrub through them and make them consistent and in another version of that data set. Once you have that, you explore to see exactly what you have. Like for example, you have data from the last 5 years, for example. So you know, okay, well, I know I have that amount of data. And you have data maybe every month. That would be a good example. And then out of that, based off of what you're trying to get out of it, you're trying to use the correct machine learning model to get information out of it. Is a classifier, you're doing a recommendation, you try to figure that out. And once you have the data and you want to process it, you want to interpret that data, because the thing is about data, especially if you're going to present it to other stakeholders, they're not data scientists, they're not machine learning, they're not AI engineers, right? So they're hiring you to take the data, get model out of it and get meaningful information in, and then interpret that for them to tell them basically what that means and what's your recommendation. So I would say the example of this is actually, if you watch Star Trek The Next Generation with Captain Picard, if you watch any of the episodes where he's faced with a dilemma, he asks his teams for their opinion, and each one of their members of their teams are experts in their field, and they give their recommendation based on the data given and their interpretation of why they recommend that, right? Captain Picard is not an expert in any of those fields, but they'll take that information and take that into consideration, but he makes the final decision. That's the same thing you're doing as an AI engineer and also like a data scientist as well, is you're taking that information, modeling and interpreting that data and giving them a recommendation so they can make an informed decision. Now I want to talk about project-based learning. So we just talk about the tech stack, the basics learned. Now the problem is now you're like stuck in like tutorial hell, right? Like you could just go down a rabbit hole of YouTube and just keep finding more and more of the subjects, especially because AI and technology moves so fast, which something that came out like 3 months ago could be really old. Something that came out last week could be old, right? So the problem is you're watching tutorials and not actually building, right? To actually fix this, you actually do a real project. That's how you actually fix it. Pick your own project, AI project you want to work on, and pick a real life problem and actually solve it. So my first production AI work was actually making prediction models for the stock market. So we were given, there's a bunch of us, basically it's up to us to go and find the latest papers, find the algorithm out of it, build it out, and actually test it against the market, back test it to actually prove that over time in the past that actually outperformed, for example, a benchmark of the S&P 500. And if it did, then okay, great. Then we actually give it to a portfolio manager and they actually implemented it, and it gives them a better return than if they just invested in the S&P 500, for example, right? What you want to do, when I suggest when you're doing project-based learning, is actually build problems you actually understand. So for example, and do it in a domain that you understand as well, right? So for example, if you're in healthcare, you might want to make a project where scheduling appointments is efficient, right? If you're in finance, you might want to build example projects where categorizing expenses are automatic, right? And if you're in content creation, you want to repurpose content across different platforms. So the main thing about this is you want to stand out. You want to have a standout factor that actual real users are using it, right? Actual daily usage, and not just hypothetical users, not like this could be happening. It's like actual people are using this, right? Basically, a way to reframe this is to actually treat your AI projects as if you're an AI startup, right? What is the best case scenario is that you actually have a project that's worth actually building a startup, and that's a win, right? You could go in and actually pitch to get an accelerator to have a startup or get some funding for that. And worst case scenario is that, okay, maybe not have a startup, but you could get hired anywhere that if you have this problem, most likely there's other people, other companies that have this problem that you could solve, right? And the other thing is you have production code with users. So if people are using it, that's one of the tractions that proves that, okay, people are actually using it. That's a really strong indicator that is a real problem that your tool is a solution for. I want to talk about one of the hardest part of this whole process is actually the interview. So in my example, my first AI job was making prediction models for the stock market, right? Before I started, I must have prepared for like 60 hours to make sure I understood all the different aspects of ML, data processing, actually deploying it, how to backtest it, how to actually present this, right? It's very brutal, yes, but it's actually required. If you're going to be working as an ML engineer, or AI engineer, even software engineering, right? You have to be able to prepare for this, right? So AI interviews differ from like software engineering in the sense that you still have to know what you need to know for software engineering. So, but you also have to master the machine learning fundamentals. Not necessarily you have to like build them all from scratch, but you have to understand it. So you're not necessarily memorizing what a gradient descent is. You have to be able to explain it, know what it is. But main thing you have to explain, like in production, you're trying to build a model and then for some reason it's not converging. So you have to understand like what are the possibilities in actually as a practitioner, why is it not converging, right? If you were to do that. Now, the thing is, as an AI engineer, you're probably going to already use models that already exist, but it also depends because you might take a model that already exists and you have options to like fine tune it. So you have to understand these process. And you have to also justify your architectural choice. A lot of times, I'll tell you the truth, what you could do, and what's commonly done as a machine learning engineer or ML engineer is that you look at papers and you look at architectures or outcomes that are very similar to what you do, and you model your architecture after that, right? So again, you have to be able to explain that. So even if you're an AI engineer and you're using models that already exist, you have to understand these concepts because it will help and handle like distribution shift, things like that, right? Now, you also have to like master machine learning system design. Again, you don't have to necessarily build out the actual models, but understand how you would design the system. Like for example, if you're going to make a recommendation system for millions of users, think, let's say Netflix, where there's literally worldwide users of this. How do you build a recommendation system in real time that will work? How do you do model versioning for your ML models? And what's your strategies of like deployment, training, replacing, while still keeping it live? And what is your A/B testing of models where you have a current model now, then you train a new one, or you're replacing it with a new one? If you're an AI engineer, you found a new one that's supposed to work better and you have another design. How do you test the metrics that this current one is working better than the other, right? You have to focus on on the actual coding part of it, not just linked list puzzles. Again, like something like you see at LeetCode and all that, you do have to know like some software engineering coding. But in the case of if you're going to be an AI engineer, depending on the level, you might have to implement like what k-means algorithm from scratch, right? Or explain that. And like streaming data pipelines, especially if you're going to be, a lot of times if you're going to be dealing with AI models, these models are most likely not local, so they're going to be big. So how do you process large data? How do you move large data? How do you stream that in? And also the secret prep system document that I did while learning during like these 60 hours here is that I would go in and try to answer questions, and every question that I miss, I log them or like flag them, right? And then I went back and assessed like, okay, why did I struggle? And then I wrote notes and spent more time of figuring out what is the correct approach for that. And then I wrote like similar problems that are very similar to the ones that I struggled with, right? After a while, at first you're going to be like very, hard on yourself, and it might seem a little daunting, but after a while I built like 50 different scenarios that you kind of look out for them. So when you actually went to the interview questions, they basically became variations of these 50 scenarios, right? And basically half already solved the pattern because you already knew what you're looking for. And it was the same thing for the software engineering coding interview portion, is that they don't want you to memorize the actual solution. It would be impossible. And just going into, let's say, LeetCode and just practicing over and over and over and over is not necessarily the best strategy. It's more of like understanding how to approach a problem. What's the way to actually approach it? And it's more of that line of the critical thinking. And if you know the general approaches of how to solve it, even if you have variations of that problem, you should be able to solve it. So here is an efficient study path. This is the exact path that I would use if I was starting today, right? So month 1, I would actually learn Python plus the data fundamentals, right? So you want to know like data science fundamentals, right? You want to know NumPy, you want to do daily practice, just understand the syntax. If you ever use MATLAB in the past, MATLAB was, I think it was like $1,000 software, but that was kind of like the de facto math software that academia used and to graphically show mathematical things. NumPy uses a very similar syntax, but it's free and very powerful. The other thing is actually pandas. That again is dealing with like spreadsheets of data. So you could bring in an Excel sheet or comma separated values.csv file in there and start manipulating it. It's actually built on NumPy. Again, all this is Python, right? And then the other thing, you want basic data visualization. So you want to use Matplotlib or like Seaborn to visualize the data so you could interpret and present it to other stakeholders so they understand what's been done, again, using the awesome framework. And here, you want to use real data sets, not just toy examples, right? So actually collecting data yourself, or show maybe from a POS, like a point of sales system, and you get that data and actually manipulate it to show some insights with that, right? So now for month 2, I would say machine learning fundamentals. So with Python, it actually there's our packages like scikit-learn, which is just traditional machine learning and is not necessarily super deep neural networks in there. So one thing after that, though, once you start learning the basics of like scikit-learn and like learning all the basic algorithms, which by default you should always start off with as a baseline. In a lot of cases, for example, linear regression, if that works in most cases, use that. You don't have to go complicated unless it gives you like significant boosts or improvement with the overhead, right? So you want to use like one. After that, I would say learn one deep learning framework. So what's the difference between machine learning and deep learning? Well, deep learning is basically, it is a neural network. It's just that if you have more than 2 layers, they call it deep learning. It's more of a, I guess, like a buzzword than it. But basically, and if you're dealing with deep learning, PyTorch now is kind of the standard. Before, TensorFlow, which was from Google, was used a lot, but it was not really Pythonic how I would use it. Then PyTorch from Meta, like Facebook group, came about, and that became kind of the standard. And then even TensorFlow 2.0 start using the methodology of PyTorch, but pretty much these days everyone uses PyTorch as a standard. So just learn that. It's easier to get along, and don't try to like make it harder on yourself by using other languages for the sake of it, right? The other thing I would say is during this month, build 3 end-to-end projects where you actually apply this stuff, or else you're just going to be reading theory and it's going to go over your head, because it's going to be a lot of or maybe like you're not necessarily go over your head. It's more of like you're not going to absorb the information because you're not actually applying it to real projects here. After that, in month 3, let me do that a little better. In month 3 over here, I would say do specialization plus actual production. So pick one area: computer vision, natural language processing, or time series, and do a project based off of that, and kind of become a master of that. So when you apply for jobs or you try to get clients, if you want to do this on your own and maybe work with local businesses, you know a certain area that you could excel at, right? The other thing as well is you want to learn deployment. Like, just because you have to build it, you actually have to deploy it so it actually used by other people. Docker containerization, be able to package everything up into a container so you avoid the problem of, well, it works on my computer. Well, if you build the entire environment and then ship that and deploy that, it will work, because it's kind of like you're putting everything on a computer and you're giving the computer with all the required hardware and setup and the environment's needs with it, right? And again, machine learning models or deep learning or AI models are pretty heavy. So most likely you're not going to run it on a local machine, or even run it on someone's local machine, because they don't have the hardware. Or even if they did, they have to have the top of the line and it would use up all their computer. So you want to learn cloud computing, so either AWS or Google Cloud Platform or Azure, so you can deploy that up there and actually see how it'll work, right? And you want to build one production system where you have real users. If real people are using it, then you actually have traction, and it's actually useful, that people are willing to act. You're actually solving a real problem that people are willing to spend their time with, right? Once you pass month 3, you have your feet wet and you're able to go end to end. You might not be perfect at it, but starting from month 4 and beyond, that's where you start doing like interview prep. Plus, you still continue making applications, right? So you still do daily coding problems, because you're still going to have to do a code. If you're trying to get a job in this, you're going to have to do a coding interview. So you want to know the standard like software engineering coding interviews, like the data structures and algorithms, and also system designs. But also, as an AI engineer, you also have to know ML or machine learning system design, right? And what I would say, all the successful people who I know network or find either jobs or make other business relationships, they at least block out an hour in the morning or sometime in the day, usually in the morning, that's when I know, and they apply. In this case, if you're trying to get a job, you apply for 5 jobs, or they reach out to 5 people for networking, right? Daily. Now, the thing is, it's kind of like going to the gym. You're not going to see results at the beginning. You're not going to see it tomorrow. You're probably not going to see it next week, right? But if you do it all the time consistently, just part of your routine, then all of a sudden when one of them actually hits and it actually works, you might seem lucky. But pretty much luck is when preparedness meets opportunity, right? So by doing all these other things like month 1, month 2, month 3, that's you being prepared. You're getting yourself prepared, right? And you have enough of your fundamentals that you're good enough to now start as of month 4, create opportunity by reaching out to people, by constantly reaching out. And when it's good, while at the same time you're continuing preparing yourself, you're getting better, and you're continuing to reach out to people. Even the right person might not notice you the first time, but then they might notice, after a while, because they're consistently seeing you. And then at the end, when the preparedness finally meets the opportunity, that's when you get lucky, right? The other thing I would mention is, once you have your base, and why I'm saying here, build one production or like pick one area, is that you want one baseline where you go end to end, because the rest of the time you're going to do just in time learning mindset. Like, you don't try to learn everything. Is that master that you get end to end to one thing, and you never know what project you're going to work on next. So it's kind of hard to anticipate. There's so many things to learn that when you know your next project, learn what you need that's missing just in time at that moment and master it. Avoid trying to master everything, because even if when you master it a month or two from now, that technique might be different, right? So you want to really master your next goal. An important part I want to talk about is the mind shift, right? Nobody tells you this truth at all, but you will actually feel stupid most of the time, like 80% of the time. I can tell you that anytime I start something new, I don't know anything at all, despite all the past credentials or work I've done before. And the other thing is, others may seem smarter than you, but that's just an illusion, right? The only difference is they started earlier. So you're meeting them when they already have that knowledge, right? You're not meeting them at the same stage you are, right? So don't let that deter you or have imposter syndrome. You just put in the time. If you have the right information and you put in the work for it, you're going to get there as well, right? And you're always going to reinvent yourself. That's just, you could do that repeatedly. That's just the nature of the business, right? I went from Hollywood film, to actually traditional film, where even analog, I was doing audio and video analog, and then went to 3D, and then combined the filmmaking with 3D filmmaking. It just so happens that VFX and Hollywood allow you to do that at the time. And then it went from 3 to like web development, and then like web development to the AI engineering and whatnot, right? So very different industries, but over the time, the past things I've learned added on to it. And in fact, a lot of concepts you could cross-pollinate and come up with a very unique solutions that others wouldn't have thought of because of how things are done in other industries, right? Now, the thing is, each transition felt impossible until it wasn't, until you did it enough, and then you start seeing the same pattern, you start solving it, and then you become comfortable with it, right? The difference is actually building something. You won't get better at it unless you actually do it, right? So if you build without fully understanding anything, that's natural, just do it. I would say you build even when it's messy, because at least you get end to end. Then you have a post-mortem, and then you assess what you did wrong. If you were to do it again, how would you do it? And by doing it over and over and over, you know the next time you're going to avoid the pitfalls and you get better at it, right? Main thing I would say, stop waiting for the perfect course. Stop waiting to understand all the math. Stop waiting for AI to get easier. Like, learn in fundamentals, learn how to get end to end, and just do it. Here's your action plan to be successful. AI engineering is not optional. Every company needs AI, whether you like it or not, it's there. The question is, will you build it? So comment below your first AI project that you will build this week, not someday, this week, right? And I will personally reply with advice on what you need to do to move forward to help you along with that, right? And my transition is proof. I started in film and 3D background. I learned AI in 3 to 4 months. Was I a master of it? No, but I was getting things done. And then when I started, my first job was actually stock market prediction. That's my first AI job with it. And I just got better after a while by actually going in it. Of course, you say that they may have this imposter syndrome, but nobody knows what they're doing at the beginning. But by doing it, you actually will get better if you're conscious at it and you're actually doing the right things, right? And if I could transition, so can you. So the main thing I want to say right now is that the only difference between you and an AI engineer is actually starting today.